All right, guys. Last video for section 1.5. And this is going to be the quadratic formula. Okay, so I'm going to run through how they came up with this formula. You don't need to duplicate this on your homework or tests. This is just for your own edification and to kind of understand the history of mathematics, how these things work. I'm going to derive the formula. So what we started with, we had this quadratic equation. And we already talked about how factoring often doesn't work, and I showed an example. And then we went through completing the square, which will always work, even if it's factorable. Although if it's factorable, in general, it's better just to factor it than to complete the square. But the process, I kind of like the process, but a lot of people don't like it, and it's like, wow, this is brutal, this is hard. So they decided to come up with the formula. Well, how they did the formula is they completed the square on this generic quadratic equation, ax squared plus bx plus c. So I'm going to just complete the square on this to get our formula. So you remember, this is good review for the steps for completing the square. The first step was divide everything by a. So I'm going to divide everything by a. Right? I divided everything by a. Next step was to move the CA over to the left-hand side, the constant term. All right. Now, we did this trick where we took this middle term, the b over a, we divided it by 2, and then we squared it. So let's do that. ba divided by 2 is 2a squared, so it's going to be b squared over 4a squared. And we're going to add this to both sides. Okay. Now, when we've done this, remember that the left-hand side is a perfect square polynomial, and the factor of it is always this with this sign with the square root of that, remember? So the factor of this is x, and it's a plus this time, with the square root of b squared over 4a squared, which is going to be this guy inside here. It's b over 2a squared. And on the right-hand side, we have this big mess. Okay, and what you're going to do on the right-hand side is you're going to make it one common denominator. The common denominator is 4a squared. So we need the c over a to be a 4a squared on the bottom. So you're going to multiply it by 4a, top and bottom. Doesn't change anything when you do that. And you're going to then have b squared over 4a squared minus 4ac over 4a squared, which then can be combined into a single term of b squared minus 4ac over 4a squared. Now we need to get rid of that square, and we do it by taking the square root of both sides. Anytime you do that, you do plus or minus. So now we have x plus b over 2a. These cancel. Plus or minus square root of b squared minus 4ac over square root of 4a squared is 2a. Okay, then the last step is we're going to move this guy over here by subtracting it. Okay, and then combine like terms. And we're done. And you have the quadratic formula. So the whole reason, I don't expect you to be able to just derive this using just symbols. But that's how they came up with the formula, is they just did completing the square on the generic a x squared plus bx plus c. Okay, And so what the formula simply states is if you have something in this form, you can solve it by plugging a, b, and c, since they're numbers, into this equation. The solution is x equals negative b plus or minus b squared minus 4ac, whole thing over 2a. And that is the quadratic formula. So, now the disadvantage of doing this is completing the square. I didn't have to memorize the formula. If you're going to use the quadratic formula, you're going to have to memorize this. Okay? Let's see how it works. So the hard part of this is memorizing the formula. Easy part is you jump straight to the answer, and it's kind of easy to plug in. So let's look at some common examples here. So here is a quadratic equation. It's in the correct form. And I don't want to complete the square because I'm sick of it. And it's video 3, right? So what we need to do is then we're going to use the quadratic formula. We need to, A is 2, B in this case is 9, and C is negative 5. And you're going to plug them in to this guy up here. So minus B, so you're going to have minus 9 plus or minus. B squared is 9 times 9, which is 81. 81 minus 4 times 2 times negative 5, all over 2 times A, which is another 2, 2 times 2. Okay, so I just plugged these values here. I plugged these values into their corresponding numbers here and then plugged them in up here. And when I did that, I got that. Okay, so now it's just basic math on the inside. So first you need to figure out what 4 times 2 times negative 5 is. Well, that's going to be positive 40. So you're going to have negative 9 plus or minus 81 plus 40. All over 2 times 2 is 4. Get that. Now what's 81 plus 40? 81 plus 40 is 121. Okay, now at this point, can we take the square root of 121? We can. It's indeed a square. 121 square rooted is 11. So then we can then go plus or minus 11 over 4. And now is when we break it into two parts. So you're going to have negative 9 plus 11 over 4. And negative 9 minus 11 over 4. Here, negative 9 plus 11 is going to be 2 over 4, which is going to reduce to 1/2. So that's one solution over here. Negative 9 plus a negative 11 is a negative 20. So this will give you negative 20 over 4, which is negative 5. And so we have our solutions, are 2 and negative 5. And we're done. So x equals 2 and x equals negative 5. So that was using the quadratic formula. Okay, let's do another one. So here we have 2x squared plus 2x minus 1. Well, A is 2, B is 2, C is negative 1. Plug them in. You're going to have B, negative B, so negative 2 plus or minus. B squared is 4 minus 4 times 2 times negative 1, all over 2 times 2, which is 4. So there, I just plugged them in. Now, this whole term here underneath the square root is called the determinant. And it's the thing that's kind of involved in calculating. It determines whether you have 2 real solutions, 1 real solution, or 2 imaginary or 2 complex solutions. So let's go ahead and work this out. So 4 times 2 times negative 1 is going to be positive 8. So then we have negative 2 plus or minus 4 plus 8 over 4, which is going to be negative 2 plus or minus 12 over 4. 12, square root of 12 is really square root of 4 times square root of 3. So we can rewrite this as square root of 4 times square root of 3. That's what square root of 12 is. Square root of 4 is 2. All right, so just took the square root here. Then you could divide everything by 2, since everything here, here, and here are all multiples of 2. So we could cancel those if you want and reduce it down to -1 plus or minus square root 3 over 2. And then, of course, you could separate your answer and get -1 plus square root 3 over 2. So this could be rewritten as -1 plus square root 3 over 2 and -1 minus square root 3 over 2. And this is going to be two real solutions, irrational but real solutions. Okay. Another quick example. Okay. Next example here. So here a equals 3, b equals -2, c equals 4. So plug it in. So remember the formula is -b plus or minus b squared over minus 4ac all over 2a, right? Okay, so b is -2, so we're going to have a double negative. So that's b plus or minus -2 times -2 is 4. 4 minus 4 times 3 times 4, all over 2 times 3, which is 6. Here, these are double negatives, so it's 2. 2 plus or minus 4 minus 4 times 3 is 12. 12 times 4 is 48, so it's going to be minus 48 over 6. We then, 44 minus 48 is -44 over 2. And -44, since the negative inside the square root, we're going to have I. So this is 2 plus or minus square root of 44, I outside, over 2. Square root of 44 is really 4 times 11, so we can rewrite this as square root of 4 times square root of 11, I over 2. I did this because I can then square root of 4 is 2, so then you have 2 plus or minus 2 square root I over 2. And then you can then rewrite it as 2 over 2 plus or minus 2 over 2 square root 11 over I. These cancel. You end up with a 1 here. 2 divided by 2 is 1. Plus or minus 1 times square root 11, which is square root 11, I. And then at this point, we've done as much simplification as we can, other than just to write it as and here we end up with two imaginary or complex solutions. Okay. So we've gotten examples where you end up with two reals and then two imaginary. There's one other possibility, and that's if the determinant equals 0. If 4 minus AC equals 0. So an example of that would be, let's look. So here's this example here. Now A equals 1, B equals -2, C equals 1. And if you plug it in, you're going to get -2, that's your B, plus or minus. -2 squared is 4. 4 minus 4 AC, which is 1 times 1, all over 2 times A, which is 2. Okay, so here is 2, plus or minus 4 minus 4 over 2. What's 4 minus 4? 0. So you're going to have 2 over 2 plus or minus 0. Plus or minus 0 is the same thing. If you add 0 to something, the same thing as subtract 0. So this really just reduces down to 2 over 2, which is 1. So you end up with a solution of of 1. So this is when you have one real solution, and it's when the determinant equals 0. Or discriminant. Discriminant, not determinant. Discriminant equals 0. I've been calling it that. So let's talk about the discriminant. Discriminant is this b squared minus 4ac, and we call this d, the discriminant. Now there's 3 possibilities. We've talked about them. We've done examples with all 3. One is if d equals 0, then you have one real solution. The other one is if d is greater than 0, then you have 2 real solutions. The last is if d is less than 0, then you have 2 imaginary solutions. And some of these problems are just going to be asking you not to actually use a quadratic formula. Just tell them whether you have one real solution, 2 real solutions, or 2 imaginary. And you do that by just examining the determinant. Okay? Or not. Did it again. The discriminant. Discriminant. Okay. Last thing in this chapter is they briefly talk about the Pythagorean theorem. Okay, the Pythagorean theorem is a long, sordid history in mathematics, all the way back to before Christ. And the Pythagorean society, there's a whole Greek thought that math is pure essence, pure reality, and that math is perfection. Reality is just an imperfect copy. It's the intangible, and they wanted to study the infinite, the everlasting, the eternal, the perfect, and so they studied math. And they Pythagoras was kind of their founder, so they called themselves the Pythagorean Society. And there's a long sordid history with them in Greek thought, which is kind of interesting. Comes with assassinations and very movie-esque sordid history of people killing each other over disagreements about what perfect numbers are what and stuff. I'm not going to go into that because I could just ramble on for hours and hours. Instead, we're just going to talk about one of his more famous theorems, and this is a squared plus b squared equals c squared. This deals with right triangles. Right triangles where this corner is a right angle, and you have your 2 sides and your hypotenuse. And it's a relationship between the 2 sides of a right triangle and its hypotenuse. They do expect you to know this, and they're going to use it in formulas in example problems like they might have right here. They might have a triangle where they have this is 15, this is 10, and they want to know what x is. Well, then you're going to go 10 squared plus x squared equals 15 squared. All right? So then you're going to have x squared equals 15 squared minus 10 squared, which we just did 225 is 15 squared. So you do 225 minus 100, go x squared equals 125, and then you take square root of that. Okay? So things like that. So you need to know Pythagorean theorem. The other types of problems they might have is they might have word problems where they give you, in the example in the book, they have this blood pressure, stochastic blood pressure, and they have this formula, and you have things like this. Here's the formula they have in the book, and they're wanting to know at what age, A is age, B is pressure, at what age is your stochastic pressure 125 for normal? This is normal stochastic blood pressure. What you do is you plug 125 equals this. And then you're going to subtract 125 from both sides. Okay, and then you're going to use Pythagorean's theorem. You're going to have A equals 0.006, B equals negative 0.02, c equals -5, and you plug it in Pythagorean's theorem, you're going to come up with 2h's, not Pythagorean's theorem, in the quadratic formula. Okay? So as promised, I'm going to leave you with 2 problems to look at and think about and ask questions on from this chapter. The first one is just a straight factoring problem, and it is factor this and solve. Okay, can you factor and solve? Okay, second one is a problem that can't be factored and solved. So how would you solve this one? Now on the second one, you can either use the quadratic formula or completing the square, I don't care which. So try to work on those, think about it, try to work on your homework. That's it for